Mark P. Otten back with you.
Okay, just a quick attachment or addendum to my R video introducing you to how to run a structural equation model in the computer program R. This is just showing you with the same basketball light the beam data set. This is just showing you how to run a couple of different estimators, estimation methods, different ways of doing the math behind the scenes to run the same SEM. So the first one is GLS, generalized least squares, and this is useful when you are when you have an interaction as part of your SEM. So the reason that the recommendation changes is because when you have an interaction in there between two variables, at least one of which is a latent variable, you can no longer assume that your variables involved in that interaction are normally distributed. So then maximum likelihood is no longer recommended to feed into your chi-square test statistic. So we switch over to GLS, and the way we do it in our code here is just in the line that you have your model specified. So this is the line where I have my basketball.fit model equals SEM, and then the statement there with the data set specified. After the data set, you just put comma estimator equals single quote GLS single quote in parentheses, and keep everything else the same, which is this is the same from my previous video here. And the thing that changes is going to be, well, for you, it's just the context. You're just running this in a different context than before when, like I said, you have an interaction or something like that in your data set, in your model, that is. So in your output down there, the chi-square test is still specified in the same location, 91.397 with 48 degrees of freedom, in this case rejected. That's like very similar actually to the one we got with the same model using maximum likelihood. But that's neither here nor there because you're just following the recommendation in this case to use GLS when your data is not assumed to be normal. Okay, so then the other one is just, instead of GLS, you go MLM in the same location. This is maximum likelihood M, which I guess stands for something. I'm not sure, but it's maybe modified. Let's just say it's modified. ML modified to use robust standard errors, which means, well, we're accounting for the situation where our data might be non-normal, and we're doing so in a different way than if we had done the GLS, which I just showed you. There's a lot of theory that goes into this stuff, and for the most part, I'm just presenting this and following the experts' recommendations. But if you ever are thinking, why this and why not that, let me know. I'm always thinking that too. So anyway, you switch over to MLM, and the purpose for this is to get, for us, is to get the Satora-Bentler scaled chi-square test statistic. And so we're going to rerun it one more time here. The Satora-Bentler scaled test statistic here is going to be 85.92, and it's next to, so we're back to maximum likelihood. The maximum likelihood chi-square is 90.41. We saw that in the previous video. The GLS one we got was slightly different, and then we have a third version here, 85.92, with, again, 48 degrees of freedom, again rejected for this model. And this, again, just allows you to have non-normal data in your data set and get an additional statistic that might be informative in that scenario. That's it. That's all for now for this particular attachment to SEM in R.